Okay, we're going to start with our warm-up like normal. So go ahead and get out your warm-up page. Feel free to pause this, answer all these questions. I'm actually not going to go over the answers, but just know that this is kind of a mixture of all the things we've done. So you might have to take out a greatest common factor. There might be a trick on one of them. So kind of be alert as you're working through these problems, but it's all factoring with these special products, difference of squares and perfect square trinomial. Just do the best you can. We will go over them on Wednesday when we get back. So if you weren't quite ready, make sure you pause or go backwards and finish your warm-up. Okay, so we're going to do topic 6 today, and I will actually not be here for the next 2 days, so I know that's a little bit rough to try to learn a new topic completely via video, but I'm going to do the best I can to break it down into small segments. So topic 6 is solving quadratics by completing the square. So numbers 1, 2, and 3 here have been rewritten using perfect square trinomials, just like we just did on the warm-up. This is solved by using the square roots method. So if you look at number 1, we have x squared plus 10x plus 25. And my marker is off as usual, so I'm going to try that again. Okay, this piece right here says it's equal to 36, right? Well, we can rewrite x squared plus 10x plus 25 as x plus 5 squared because it is a perfect square trinomial, okay? The first and last terms are perfect squares, and the middle is 2 times the square roots put together. Well, looking at what I turned it into, I can just solve that by using square roots, right? So if I take the square root of x plus 5 and the square root of 36, that's going to give me x plus 5 equals positive 6, and x plus 5 equals negative 6. Okay, just like the square roots method we used yesterday. So then I just subtract 5 from both sides, so x is 1. Subtract 5 from both sides here, and x is negative 11. Those would be your 2 answers, your 2 roots. Okay, so same thing here with number 2. The original problem was 16x squared minus 8x plus 1. That equals 49. But I can change that circled piece into a perfect square trinomial, right? 4x minus 1 all squared equals 49. Then again, I can solve it using the square roots method from yesterday. I turned it into 1x, so I'm able to do that. So I take square root of both sides. So 4x minus 1 equals 7, and 4x minus 1 equals negative 7. So then I work backwards. 4x equals 8, divided by 4. So x equals 2. There's one answer. I'm going to add 1 here. So 4x equals negative 6. So x equals negative 3/2. There's my other answer. There's my 2 roots. Okay? So y'all try the last one. It's the exact same thing. This has been changed into its factored form, x plus 7 squared. Okay? So what would I do next? I would take a square root of both sides. So I've got x plus 7 equals square root of 13, and x plus 7 equals negative square root of 13. Obviously, it's not a perfect square, so I can't really break it down, but that's where we're at. So now I subtract 7, subtract 7. So really, I could rewrite this as negative 7 plus or minus square root of 13. This one is the positive version, this one's the negative version, but no matter what, I've got a negative 7. So that would be your answer for the third one. Okay? What's important here, though, is that it actually started out differently. So we talked about yesterday, you're only able to solve by working backwards if you have 1x, but these problems all started with 2 x's. Okay? I just factored it, and I was able to actually just work with square roots. Okay? So, to solve the following by using square root method. So looking at this one, oh man, I need a new board for Christmas. Let's see if I can do this. Okay, so using this right here, that is a perfect square trinomial, just like our warm-ups have been showing us, right? So square root of x squared is x, square root of 16 is 4. I put a plus in the middle because of this sign right here, and that squared should equal 64. Well, now that I've written it that way, it's exactly like the problems from yesterday, and I can just work backwards. Okay, so I'm going to take the square root of both sides. So I've got x plus 4 equals 8, and x plus 4 equals negative 8. So now I just subtract 4. So x equals 4, and x equals negative 12. Okay, so let's do it again. Looking at number 5, again, I want to take what's written right here, sorry, the word's crazy, and turn it into its factored form. Well, I know the square root of 4x is 2x. The square root of 81 is 9. They've got a minus sign in between them, and that squared should equal 100. All I did was take this boxed-in thing and turn it into its factored form, and now I'm able to work backwards. So I'm going to take the square root. Oh my goodness, y'all. That's crazy. Look at that. That's me drawing a straight line. Anyway, so that leaves me with 2x minus 9 equals 10, and 2x minus 9 equals negative 10, because I'm taking the square root of both sides. So I'm going to add 9. So I get 2x equals 19 divided by 2. X equals 19 halves. Over here, 2x equals negative 1 divided by 2. So x equals negative 1 half. Okay? So see if you feel like you could try this last one. Start by taking the trinomial on the left and turning it into its factored form. Go ahead and pause it here and try that on your own. Just turn it into its factored form that looks something like this. Okay, so hopefully you came up with 3x plus 1 all squared. So now at this point we can start working backwards. We take the square root of both sides. So 3x plus 1 equals square root of 20, and 3x plus 1 equals the negative square root of 20. We're going to break that down here in a second some more, but for now I'm just going to leave it as 20. So now I can subtract 1 from both of them, right? And then eventually I'm going to divide by 3, okay? But let's look at this. No matter what, I'm taking the square root of 20. It's just 1 is positive and 1 is negative. I'm moving a negative 1 over there, and then I'm going to divide by 3. So really, this is what your answer ends up looking like, which is kind of crazy and complex, but that really is the answer. The only thing I could do to simplify this further is to take that 20 and change it into 4 times 5 and take out the 2. So it could look like this, but honestly, looking at this is kind of scary enough. So if you don't break it down further, that's okay. Okay? So don't worry about that problem too much if you were like, ooh, I was getting it until then. So really what you're doing here, what this process is called completing the square. So what it does is it creates a perfect square trinomial. Okay? Perfect square trinomial within an equation. So you take an equation and you break it down to create a perfect square trinomial. Then you solve it using square roots like we did yesterday. So here's a problem, number 7. It says x squared plus 6x minus 16 equals 0. I want to turn it into a perfect square trinomial. Well, I know that what that means is that the first and third term are perfect squares. Well, x squared is a perfect square. The square root would be x, right? 16 is a perfect square. The square root would be 4. However, we've talked about this before, we can't have a negative here. So what we're actually going to do is we're going to create for ourselves a situation that will work. So I'm going to start, looking over here at the steps, with this. Move c to the other side. So I'm actually going to move c over by adding 16. Okay? And I'm leaving a space there on purpose. So x squared plus 6x something equals 16. Now I want this left-hand side to become my perfect square trinomial, right? So I have to think about what would I want here. Well, for this to work, this needs to be a perfect square, which it is. This needs to be a perfect square, and their square roots have to come together and double to equal 6x. Well, let's undo the doubling. What was 6x before it was doubled? Well, it had to have been 3x, right? Well, what was put together here in the middle to give us 3x? Well, clearly the x from here and a 3 from here. Well, what number would be above this to give us the 3? It has to be a 9. Now, this is an equation, so I can't just go adding 9s wherever I want to. I have to keep it balanced, so I need to actually add a 9 to that side. What I've done is I have now created an equation that will work, okay? I'm going to take this whole thing and simplify it a little bit more. I now have a perfect square trinomial, so x plus 3 squared. And then over here, 16 plus 9, that's 25. Now this is like easy peasy to solve, okay? So I'm going to take a square root of both sides. So x plus 3 equals 5, and x plus 3 equals negative 5. Subtract my 3's. X is equal to 2, x is equal to negative 8, and there's my answers. Okay? So let's kind of refresh the steps we just did. We moved the c the other side. That was the first thing. Then we found the value that would complete the square and added it to both sides. That was the green 9 up there. We realized that was what was going to help me make the left side into a perfect square trinomial. So I added a 9 to both sides. Then I factored the perfect square trinomial. That was the blue step. And then I just proceeded with solving. Okay? So we're about to practice this a few times. So if that was a little bit like, whoa, just hang on. So let's just first start by talking about how to create a perfect square trinomial. Before we just go through the whole process again, let's just practice that one part of it. So x squared plus 6x plus 9. If this were a perfect square trinomial, this and this would be perfect squares, right? X squared is, it gives us the x. But I don't know what this last number is, okay? So I want to think through, well, what would this middle term have been before I doubled it? Oh, this is the same as the one we just did. Boo. But that's okay. It would have been a 3x, right? Because it was the thing that was doubled to create 6x. Well, the x contributed to the 3x, but that means there had to be a 3 over here that contributed to 3x. Well, what number would go up here that I would square root and make that 3? It would be a 9. Sorry, my 9 didn't end up in the box. Let's see if I can do that a little bit better. Oh, I went too high. Oh well. So let's try that again. Okay, this middle problem. 7x. That has been doubled, right? Oh man, this is a yucky problem. You know what? I'm not there, but let's change this. I want you to cross out that 7. I want you to make it an 8. Let's do an 8 instead. So if I've got an 8 there, and I know that this has been square rooted to equal something, this has been square rooted to equal something, they've been put together and doubled to create 8x. Let's work backwards. 8x before it was doubled was 4x. Okay, so 4x had to be a combination of two things. Combination of this x and obviously a 4, right? Well, what does that make this thing up here? Well, something that was square rooted to give me a 4. So a 16. Okay? So look at number 10. Very similar. This time I want the middle term. So these two things, we square root, so we get x and 5. They come together on the inside to make 5x. And they double, and it would be a 10x. Okay? I feel like I need to do one more example. I know this isn't on your notes, but I'm going to do one more example. So if I have x squared plus 14x plus something, let's break that down a little bit. This 14 was the result of doubling 7x. Well, the x is the thing that contributed that x. So this had to contribute the 7, right? Well, what square rooted is a 7? 49. Okay? I can give you one more if you want. Here's one more. X squared minus, oh, and by the way, the plus and minus doesn't matter. You'll notice this one had a plus, this one had a minus, this one had a plus, this one I'm about to give you a minus, that doesn't matter. Let's do x squared minus 10x plus something. So y'all try that one. Pause it, work it out, and then push play to see if you've got it. So this doubled was obviously 5x beforehand. This contributed the x, so this had to contribute the 5, which means this is a 25. Okay? So let's continue this process that actually will give us the roots, because all this was doing was helping us set up the equation. This is how we actually get the roots. Okay? Remember, it's equal to 0 because that's giving us the roots. So x squared minus 12x plus 5. Well, that is not a perfect square trinomial because 5 is not a perfect square, right? So we need to make this work for us and complete it so that it is a perfect square trinomial. So you're going to start by moving that c that doesn't work over to the other side. So I've got x squared minus 12x plus something that I don't know yet equals negative 5. So I need to think, okay, what would work right here that will make that a perfect square trinomial? Well, again, the 12 before it was doubled was 6x. The x squared is what's giving me the x, so this needs to give me a 6. So I'm thinking plus 36. But if I'm going to add 36 on that side, I need to add 36 on this side. Okay, so now I can factor this side. That's a perfect square trinomial. So it's just going to be x minus 6 squared equals negative 5 plus 36. That gives me 31. Now I just start with my square rooting, working backwards. So I'm going to take the square root of both sides. So x minus 6 equals, and I'm actually just going to write plus or minus the square root of 31. Instead of splitting it into two pieces, I'm just going to write plus or minus. So then I add 6 to both sides. So x equals 6 plus or minus the square root of 31. And even though I'm only boxing in one thing, it looks like I have one answer. The plus or minus there actually implies that this is two answers. It's both 6 plus square root of 31 and 6 minus square root of 31. Okay? So let's try the next one. Again, I want a perfect square trinomial. 18 is not a perfect square, so I need to move it over. I'm just going to get rid of it for now. Set it on the side. So x squared plus 3x plus something gives me 18. Well, I want this inside to be a perfect square trinomial, right? Okay, here's where things get weird. 3x. The x squared is what gave us the x. Oh, no, see, I'm doing it wrong. What was 3x originally before it was doubled, right? 1.5. But we've never had decimal before. This is actually 3 halves x, okay? Because for it to be doubled, I don't want to do this problem. I'm afraid I'm blowing all of your minds, and you're like, holy cow. Let's back up. Ready? I'm changing the problem on the fly. I want this to say x squared plus 4x. Okay? We're just doing a new problem. Sorry. I'm sure you are all writing that down, and you're all ticked at me now that I made you erase it. But you'll thank me here in a second. So I'm still going to move the 18 over. So I've got x squared plus 4x with an 18 on this side. So now I'm trying to think about what would fit here. Well, again, this before it was doubled was 2x. X squared is what gave me the x. So what square root would give me the 2? Well, a 4. So I'm going to add 4 to both sides. So then I turn this into a perfect square trinomial. I factor it. So I've got x plus 2 squared equals 22. And then I just square root it. So x plus 2 equals plus or minus the square root of 22, because it's not going to come out evenly. Then I subtract 2 from both sides. So x equals negative 2 plus or minus the square root of 22, which again is really two answers in one. I just haven't broken it down for you. If I wanted to break it down, I would say negative 2 plus square root of 22 and negative 2 minus square root of 22. Those would be your two answers. All right, last one. This one, they've actually already moved the c over for us, so we don't have to worry about moving the c. But I still want to figure out what could I add on this side that would create a perfect square trinomial. Well, something goes here. This is the result of doubling 4x. The x is what gives me the x. So what gives me the 4? Well, 16. If I add 16 there, I have to add 16 here. So then I go ahead and factor this. So it gives me x plus 4 squared equals 36. Then I can start square rooting. Square root of both sides. So x plus 4 equals plus or minus 6, right? It's not a square root, but I can still write plus or minus. So I'm going to subtract 4. X is equal to negative 4 plus or minus 6. Here's where you can actually work it out. This literally means two things. It means negative 4 plus 6, so that would be 2, and negative 4 minus 6, which would be negative 10. Okay? You also could have broken that up into two problems and written it the long way, like x plus 4 equals 6, x plus 4 equals negative 6. Both of those will work.